VMs.
I can warp. I'm here.
This will be a fun one. If you're talking, I can hear you. Okay, think now.
I think we should be about ready to start. Are the people recording? Yeah, okay. This talk will be about my journey in implementing proper entity support for PolyMC and how I've made code that can analyze entity renderers. This will be a pretty technical talk, but I'll try my best to keep it understandable, at least for someone with a bit of programming experience. Before diving off the deep end, I'd like to handle some context first. If I can aim at the button. Yes. I'm the developer of PolyMC, a project that attempts to make other mods server-side compatible. What this entails is that PolyMC will, for example, replace every single item on the server with a vanilla item, and then retexture that item using custom model data and add everything to a resource spec. The end result is that the item looks exactly the same whether you have the mod installed or you're using a vanilla client with a resource spec. PolyMC does something similar for blocks and attempts to do something for GUIs and entities as well. That last one will be the focus here. In order for PolyMC to display modded things, it needs to know what they look like. For items and textures, this is easy. Mods actually just contain resource specs, and for items and blocks they just put JSON files in the right location. These files can just be copied over to the resource spec and that'll work. But for entity models this isn't the case. At the moment, PolyMC can't know what an entity looks like. It has all of the stuff ready in the API to start replacing entities, but it can't do much automatically. So let's take a look at how the average entity gets rendered. Oh gosh, that's unreadable. Never mind, but this is the client initializer, and that's where the entity renderer gets registered, as well as an entity model. We'll get to the model later, but let's first focus on the entity renderer. Of course, the fact that this happens in the client initializer is already a problem, because PolyMC runs on the server and client initialization doesn't get run there. Most of the classes needed for this don't even exist on the server. But let's first take a look at the entity renderer before getting to that problem. The entity renderer defines a piece of code that gets run whenever Minecraft wants to draw an entity on the screen. This piece of code is the sole thing that determines what an entity looks like. This is an average example of an entity rendering code. Unfortunately, it is illegible, but we'll deal with that. Other entities will have different code, but for the sake of an example, we'll use this one. For some of you who have never written rendering code before, the matrix stack is quite an important thing. The TLDR is that it stores transformations. Every single thing you render, if you add like a downwards transformation with a matrix stack, then everything you render with that matrix stack is now slightly lower. You can also scale things, rotate things, etc. All the positionings and rotations of every cube that Minecraft renders is determined by a matrix stack. So it's quite important for how an entity looks. This is only a small excerpt, but the entity rendering method does a bunch of stuff. For example, it adds a rotation depending on where the entity is facing, and it also rotates the entity to be lying down if it's in a bed. It does a bunch of this stuff. Some mods might not use this code, some mods will add their own behavior into this, and that behavior could be anything. It could be any arbitrary code. A modded entity might display differently based on what dimension it is in, or it might change size depending on its health. The point is, we need to be able to handle any situation. Now, let's skip ahead a bit in this excerpt. It has a bunch more behavior, but eventually it handles control over to the entity model we saw before. Don't be fooled, this entity model separation makes the code cleaner, but it still contains arbitrary code, so it's basically irrelevant. Not even all vanilla entities use this system, and certainly not all modded entities. But for the sake of example, let's switch to my entity model. It contains one single cube. It's defined here. It's a 16 by 16 by 12 cube, and in the top right corner you can see it in game. I got a professional texturing artist to make this wonderful debugging texture. Here's the rendering method, and this rendering method is simply a wrapper for the method I'm actually interested in. Presentation isn't working, but that method is the render cuboid method, which takes in a cube, which is, it only stores the size of the cube, and the size is pretty much fixed, and it takes in a matrix stack to position, scale, rotate that cube. Okay, what were we doing again? Okay, we need to find a way to extract all of this information out of this Java code. First things first, if we want to find the entity renderer, we need to find it first. Recall that it is... where are we? Recall that it's registered here in the initializer, and we can't run. We don't have access to that. You could start up a Minecraft client and let it run till initialization, but that will take a while. Instead, we're going to write a custom JVM to handle this. When a mod is compiled, what's stored inside the jar isn't the code you wrote. Instead, it's compiled to Java bytecode. I'm not going to go too far into details, but the TLDR is that it's a list of instructions. For example, the I add instruction takes in the two integers that were last produced and adds them together. It's the JVM's task to execute each of these instructions in order. If we encounter this add instruction, we can grab the last two values, let's say a 1 and a 1, and then we can output a known 2. Just adding some basic instructions like this means you can already execute a bunch of programs. And I've got a little trick. Say we stray too far from the client initializer and we encounter some weird internal method which requires complex stuff. Well, we can, instead of returning a known value, we can return an unknown value. Basically saying we gave up executing this method, we don't know what it returned. Note that normal JVMs don't have this. It's different from being null. If something is null, then we know it's null. If something is unknown, it might be null, but we've got no clue. How I've represented this is to create like a class that either stores a known value of x or a unknown value. And this is how all things in the JVM are stored. Now we're ready to execute the client initializer inside of our custom JVM, and we don't have to worry about this causing weird errors or trying to start rendering something or any other side effects. It can only do what we told our virtual machine to do. And when our virtual machine hits one of the register instructions, we can just log what it registered and store those values for later. So now we've got the entity in renderer, and now we can start analyzing it. Let's take a quick look at what we need again. What we need to know is which cubes are being rendered. This means size and most importantly their texture. This needs to resolve to a finite set of cubes because each of these needs to be added into an item model, which is then added to the resource spec. Luckily, I don't think it's possible for a mod to have infinite amounts of different cubes unless they're doing something really cursed. Secondly, we need to know where that cube is being rendered. This means the scaling, rotation, and translation. We don't need to worry about these aspects individually though, they're all stored in the matrix stack. These last values are more interesting than the first because they aren't a fixed number. Say you have a pig. The direction this pig's head is facing isn't fixed. It depends on the direction in which it is looking. You can't say that it's like 45 degrees because, well, that would be inaccurate. It might be 45 degrees at some point, but it's not 45 degrees constantly. How we could think about this is that we need to enumerate all possible ways in which the entity rendering function could call that render cuboid function. And we need to figure out how the matrix stack passed into that function came to be. Luckily, I didn't go write a small virtual machine for nothing. You know that unknown value, representing values that are completely unknown? We can expand on that. How about a value representing something that's not known currently, but will be known later, such as the entity itself? Because we don't know any of the properties of the entity yet. How is that pig flying? Okay, I'm not going to worry about that. We don't know any of the properties of the entity yet. We want to see how the renderer behaves for any possible entity, such that we can create a resource spec that can deal with any possible state the entity is in. Let's grab an example. This is some pseudo. Oh no, is it not? Yes, this is some pseudocode. The cube is created inside the JVM, so we always know it. It's just a known value. And let's move on to the next line. We don't know what the entity is, so the entity will just be a mocked value. We do know its class, which is quite important, but nothing else. Next, we are accessing a field of the entity, the health. We don't know what the health is either, so we'll create like a mocked field which stores the health, and we'll store the fact that it comes from the entity. But besides that, we don't know anything else. Let's see if any of these slides are actually working. None of the slides are working, so we're going here. Next up, we're dividing the health by 2. We can do a similar trick there, creating a math operation and returning that. And storing the fact that we're dividing the health by 2, but still not getting into any concrete numbers. As you can imagine, these values can get nested very deeply. And after that, just looking, my slides are completely broken. We now know that this function renders a cube at, and we know the location. We know that it's scaled with health divided by 2. And this handles basically everything except if statements. If statements are really annoying because you can't execute the if statement because it maybe it's supposed to not execute. You don't know if it's supposed to execute. The only option you have is to both execute it and not execute it. You're going to go down both paths. This is a pain. You need to copy the entire virtual machine state, and you need to let both of them run to completion. You need to keep track of which calls happens in which branch, and you're going to get a lot of branches. The little test entity I made, it does approximately 40,000 code paths. This is because it reuses the vanilla renderer, and the vanilla renderer checks for things like, is the entity named Dinnerbone, or is the entity sleeping, or whatever. Yes, this will run into the halting problem. Luckily, most renderers do complete. If you have a renderer that doesn't complete, something's wrong with your renderer. But even with all of these branches, what we're doing is completely doable. PolyMC has a functioning API for renderers, and it wasn't too hard to plug that into the information we got here. Let's see if we can. Here are some results. This is the snail from Lovely Snails. Textures aren't working yet because I didn't have enough time. But as you can see, it is working. In the top left corner, we have a regular snail. In the bottom left corner, we have a dinner-boned snail. And because of the way that we are actually analyzing the entity renderer, this means all custom behavior is working, which means that if the snail is threatened, it will actually go into its little house. And that's all working. The snail is going backstage. Get in. Nah. Of course, there was a bunch of... no, it's fine to let the snail wander around. I don't care. Of course, there was a bunch of trouble along the way. I had to do a few optimizations. You have like, sometimes you have a situation like this code where it checks the same thing in multiple places. This usually is in a different method, but nevertheless it does check the same thing twice. Of course, we don't need to create 4 different paths to represent this. 2 is enough. So what I do is basically, if we're going to go down a path, we check if we branched on that condition already. And if we did, then we just ignore it and take the previous results. Another situations is this situation. You might think that the code on the left doesn't happen, like nobody would write this kind of code. That is true, but the Java compiler will actually transform your code to be looking something like this. In the situation on the left, we don't actually have to branch, because we could basically just return a mocked object which contains the result of x equals 0. As for the right hand side, the code in the branch does do something, but it doesn't influence the rest of the program's execution. Assuming this method doesn't modify the matrix stack, assuming the method doesn't modify the matrix stack. So we'd only need to split into 2 branches temporarily, and after this statement finishes, we can just